Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Before we start our lesson, we will begin with reciting surah. The first one will be Surah Al-Fatihah, Surah Taha ayat 1 hingga 5, Surah Al-Insyirah, Surah Al-Kafirun, and then Surah Al-Ikhlas by 3 times. After that, followed by selawat ke atas Rasulullah sallallahu alaihi wasallam. Kita niatkan selawat kita ni untuk memenuhi perintah Allah Subhanahu Wa Taala. Kita niatkan selawat kita ni untuk memenuhi hak Rasulullah Sallallahu Alaihi Wasallam. Kita niatkan selawat kita ni untuk mendapat syafaat Rasulullah Sallallahu Alaihi Wasallam di akhirat kelak. Dan kita niatkan segala bacaan surah dan selawat kita ni untuk kedua orang tua, keluarga dan seluruh umat Muhammad Sallallahu Alaihi Wasallam. Kemudian doa sebelum belajar, semoga dengan usaha ini akan membantu pelajar agar mudah memahami dan dibukakan hati para pelajar untuk mencintai ilmu. Okay?
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم
الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. بسم الله الرحمن الرحيم طه ما أنزلنا عليك القرآن لتشقى إلا تذكرة لمن يخشى تنزيلا ممن خلق الأرض والسماوات العلى الرحمن على العرش استوى. بسم الله الرحمن الرحيم ألم نشرح لك صدرك ووضعنا عنك وزرك الذي أنقض ظهرك ورفعنا لك ذكرك فإن مع العسر يسرا إن مع العسر يسرا فإذا فرغت فانصب وإلى ربك فارغب. بسم الله الرحمن الرحيم قل يا أيها الكافرون لا أعبد ما تعبدون ولا أنتم عابدون ما أعبد ولا أنا عابد ما عبدتم ولا أنتم عابدون ما أعبد لكم دينكم ولي دين. بسم الله الرحمن الرحيم قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد. بسم الله الرحمن الرحيم قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد. بسم الله الرحمن الرحيم قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد.
اللهم صل على محمد وعلى آل محمد 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 محمد اللهم صل على محمد وعلى آل 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 محمد
Doa sebelum belajar. Bismillahirrahmanirrahim. Allahumma aftah alaina hikmataka wanshur alaina min hazaini rahmatika ya arhamar rahimin. Ya Allah, bukakanlah ke atas kami hikmat-hikmat-Mu dan limpahilah ke atas kami khazanah rahmat-Mu. Wahai yang maha pemurah lagi maha penyayang.
Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Ya Rabbku, lapangkanlah untukku dadaku dan mudahkanlah untukku urusanku dan lepaskanlah kekakuan dari lidahku, supaya mereka mengerti perkataanku.
Amin.
Amin, amin, amin. Ya Rabbal Alamin. In this session, we will discuss about probability, and we're going to cover 3 subtopics. First will be complementary events. Second, mutually exclusive outcomes. And last one, as usual, theoretical probability and experimental probability. Okay, and this will be our last topic for this year. Alright, now can you please get ready with your notes, page 122 until 135, and your worksheet, page 83 until 88. Okay, now complementary event. Learning objectives. At the end of the lesson, students should be able to explain that if the probability of an event occurring is P, then the probability of it not occurring is 1 minus P. Steps to success. First, identify the complementary event. Second, calculate the complementary event, which 1 minus P probability of event. And last one, identify that probability of events plus with probability of complementary events will always equal to 1. Okay, now, what is actually complementary events? Complement of an event means all outcomes that are not the events. Alright, and I will come out with more example in our next slide. Okay, let us see the examples of complementary events, such that the event is tossing a tail on a coin. So the complementary event will be tossing a head on a coin, like that, alright? And for example, the event is rolling a 6 on a die, and the complementary event will be rolling any of the other numbers from 1 to 5 on a die. Die is a dice. Dadu. Alright? And if the event is raining, so the complementary event will be not raining. And last one, if the event is being born on a Monday, so the complementary event will be being born on a day other than Monday. So it can be Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. Alright? So if you're able to realize in my previous explanation, complementary event is actually the opposite of the event. Okay, I repeat myself. Complementary event is actually the opposite of the events. And when we add the two probabilities, the probability of events and the probability of complementary events, it always come out with 1. Okay, the maximum will be 1. All right, I repeat myself. The probability of the events plus the probability of complementary event will always come out with 1. So the complementary event can be written like this. Alright. And if we relate these complementary events with our number bond, it can be visualized or illustrated like this. Okay. Probability of even plus with probability of not even. This is the complementary. We have a dash above here, right? So dash above here mean not the even. Okay, not the even. And both of them will sum up to 1. And 1 will be the maximum value. Right? For probability, 1 is the maximum value. Let us proceed with this example 1. 1a, what is the probability of rolling 2 on the standard die with 6 sides? Okay, so the even here will be 2, right? Even here will be 2, so the probability of 2 will be 1 out of 6. And therefore, not rolling 2 will be 1, 1 minus 1 out of 6. That is how you got 5 out of 6. Okay? And 5 out of 6, when we plus with 1 out of 6, will give you 1. Okay? So, this one will be the complementary event. And this one will be the event. Okay, let's try this example 2. A pack of 20 cards contains 10 red, 6 yellow, and 4 green cards. One card is drawn from the pack at random. Find the probability that this card is yellow, and not green. I will give you 2 minutes to try. One minute left. Okay, now for part A, the probability of yellow will be, the yellow is 6 and the total altogether is 20, right? So we simplify this one, you will get 3 out of 10. So 3 out of 10 is your final answer. And not yellow will be 1 minus this probability of yellow. And this will be the event, and not yellow is the complementary event. Okay, so 1 minus 3 out of 10. Therefore, the probability of not yellow will be 7 out of 10. And again, we can illustrate this with number bonds. P yellow is the event, P not yellow is the complementary event, and when we add both of them, it always give you 1. Okay, and not green. So of course, not green is the complementary event because the event is given is green. Therefore, not green is the complementary event. And how are we going to find this complementary event? 1 minus the probability of the event. And the event here is green. And green is 4 out of 20. And when we simplify, we'll give you 1 out of 5. And the probability of not green will be 1 minus 1 out of 5, and the answer is 4 out of 5. Okay, so this the complementary event. Okay, it's not that difficult, just be careful with your calculation. Next. In this slide, we will cover example 3 and example 4. So example 3 is the probability of picking a red sweet from a bag is 0.05. Here we using decimal, so you can give your answer in decimal, okay? You don't have to change the answer in fraction. So find the probability of not picking a red sweet. Right? Example 4. In a laptop shop, there are 16 defective laptops out of 200 laptops. If one laptop is taken out at random from this laptop shop, what is the probability that it is a non-defective laptop? Okay, so I give you 2 minutes to answer both of these examples. One minute left. Okay, now for example 3, the given probability here is a red sweet, right? So the even will be this red sweet, and not picking a red sweet will be the complementary even. And it's just simply like this. P bracket probability of not picking red sweet will be 1 minus this 0.05, and therefore the answer is 0.95. Okay, and example 4, the even will be defective laptops. So this non-defective laptop will be the complementary even. Okay, so you need to give the answer of probability that it is a non-defective laptop. So 1 minus 16 divided by 16 out of 200, and the probability of non-defective laptop will be 194 out of 200, and you can leave your answer as fraction or in here. If you want to change it into decimal, it's up to you, but in exam it's enough for you to give in fraction also. Okay, so I just put it here, or 0.92. All right, next example 5, the last example for this complementary event. Okay, Mahesa records how 120 students from year 7 and year 8 travel to schools. Okay, each student walks, cycles, or travels by bus. And here will be the statements that you can use to complete the table. The first one, 48 students are in year 7, 77 students walk, 5 students in year 8 cycle, 36 students travel by bus, 4/9 of the students who travel by bus are in year 7. So your task is you need to complete the table here, and you need to answer part B. One of the 120 students is chosen at random. Work out the probability that this student does not travel by bus to school. Okay? And I give you 2 minutes to try. One minute left. Okay, now let us do this. The first information is 48 students are in year 7. So look for year 7, and 48 will be here. Okay? 77 students walk. So look at walk, and the total is 77. Put it here. 5 students in year 8 cycle. So look for year 8 and cycles 5 students. Put it here. 36 students travel by bus. So bus and 36 will be the total for students, both for year 7 and year 8. Okay. 4/9 of the students who travel by bus are in year 7. Okay. We know that total for students who travel by bus is 36, right? So 4/9 of 36 will be like this, 16. All right. So you already fill in all the information given. So look at the table and you just need to complete the missing box. Okay. So from here, the total is 120 and year 7 is 48. So how are you going to find year 8? It should be 120 minus 48 and will give you 72. Okay, repeat the same thing for bus and you should get 20 for year 8. The travel by bus. And if you look at these cycles, you may stop here because we don't have the total. But if you look at the total at the bottom here, we only have one part missing. If you can relate this with algebra, this is actually applying algebra. Okay? And this missing part will be x. Alright? So, how are you going to find the cycle? 120 minus 77 minus 36 and will give you 7. And then by this you will get year 7 that travel by cycle 2 and again you will be stuck here. You only know total, but remember when you look at here the total is 48 student, right? So how are you going to find walks? 48 minus 16 minus 2 will give you walk. Okay, 30 students and same goes with walk for year 8, 47 students. Now, one of the 120 students is chosen at random. So, meaning here, we choose student randomly, and you need to work out the probability that this student does not travel by bus to school. So you need to pick up student that travel by walk or by cycles. By walk and by cycles. Okay. And actually, the event here is travel by bus. So the complementary event will be travel by not using bus. Okay, so bus total here is 36. So the complementary event will be 120 minus this 36. Like this. Alright. So 84 out of 120 when you simplify will give you 7 out of 10. Okay. I repeat myself. The event here is probability of travel by bus, and does not travel by bus is the complementary events. This one you can write as, let's say the event for bus you write down as B like this, and the complementary event here you can write like this, P bracket B and dash above here. So this one represent complementary event. Now, let us move to mutually exclusive outcomes. The learning objectives. At the end of the lesson, students should be able to identify and record systematically all possible mutually exclusive outcomes for simple combined events using lists, tables, and tree diagrams. Steps to success. First, record data by listing, table, or tree diagram. And the second one, find out the mutually exclusive outcome. Okay. Example 6, and in these examples, we're going to identify and record. Example 6, 7, example 8, 9, 10, 11, and example 12. They are all about identifying and recording systematically all possible mutually exclusive outcome for simple combined events using first listing, tables, and also tree diagrams. Okay, and example 6, this one is by listing. How many different three-digit numbers can be met using the digits 2, 4, and 6? How many difference? Okay, so you can try like this. Step 1, list down all the numbers that can start with 2. So you will get 246 and 264. Step 2, numbers that start with 4. So 426 and 462. And then step 3, numbers that start with 6. So it will give you 626 and 642. So how many different three-digit numbers here? You have 6 different digit numbers. There are 6 possible numbers, and how you're going to write down the answer is like this. Okay, you list down. So 246, 264, 426, 462, 624, and 642. So this one is by listing. Okay. Example 7. There are 2 bags. Each bag has 3 counters inside. In bag 1, there is 1 red counter, 1 green counter, and 1 pink counter. In bag 2, there is 1 blue counter, 1 yellow counter, and 1 red counter. Zuhdi takes a counter at random from bag 1 and a counter at random from bag 2. So, part A, write a list of all the possible combinations of the 2 counters that Zuhdi can take. For example, here I put RB. RB is stand for red and blue. You don't have to write the full full spelling. You just can use the initial R and B. R for red, B for blue, and G for green, P for pink. Okay? And then the part B, you need to find the probability that Zuhdi takes 2 counters that are the same color. And here I already put the probability here, P, probability of same colors, and you just need to find the value. Okay, I give you 2 minutes to try. One minute left. Okay, now. Okay, so we list down all the possible combinations of the two counter here. First one already written for you. The first one is RB, red and blue. So the next one is red and yellow, RY. And then RR, red and red. Okay. And second, green and blue, GB. Then GY, green and yellow, and green and red. And next, pink and blue, pink and yellow, and pink and red. So here are the 9 possible combinations of the two counters. Okay. And for part B, you need to look for the probability of same colors. And if you can see here, we only have one double. Okay. RR here. So RR mean they have same colors. Therefore, the probability of the same color will be 1 out of 9. 9 is the total possible combination. This one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay, next. For this example, example 8, here we're going to find out the mutually exclusive outcome by using table. And 2 dice are rolled at the same time and their scores are added together. Find the probability of the sum of the 2 dice equaling 7. So here we need to find out the sum of the 2 dice equaling 7. So you put them into a table and don't forget to put sum here plus. This will be the first dice and here will be the second dice. Okay, now. So we fill in everything in this table. So 1 plus 1 will give you 2, 2 plus 1 will give you 3, 3 plus 1 will give you 4, and so forth. Okay, we complete this one. Until 6 plus 6. And this one already completed in your notes. So you just need to try to understand how this method apply to find the mutually exclusive outcome. Okay. So the question asks you about probability of the 2 dice equaling 7. And here you can see the answer 7 here. And you need to count how many 7 that you got in this table. Okay. Okay. Final 2, 5 plus 6 is 11. 6 plus 6 is 12. Now, you need to find out how many answers that equal to 7. And here will be the answer. Okay, 1, 2, 3, 4, 5, and 6. So we have 6 outcomes that equal to 7. And the total outcome here is 36. Okay, the total outcome here is 36. And the probability of rolling 2 dice and the sum being 7 is 6 out of 36. And when we simplify, it becomes 1 out of 6. Next, example 9. Islin has 2 fair square spinners A and B. Spinner A is numbered 1, 2, 2, 4. And spinner B is numbered 3, 3, 4, 5. She spins both spinners, and adds the two numbers, 8. Okay, plus. And if you see this kind of question in exam, these questions involving mutually exclusive outcome. So if you realize the question is about mutually exclusive outcome, then you need to record the informations either by listing, by table, or by tree diagram that you're going to cover after this. Okay, and in these questions you already given the table, you just need to complete the table. Okay, and part B, you need to find out the probability the total is 5 and the probability that the total is more than 5. I will give you 2 minutes to try. One minute left. Okay, now let us complete the table. So 4 plus 1 is 5, 5 plus 1 is 6, and here 4 plus 4 is 8, and 5 plus 4 is 9. Okay, and probability that the total is 5. So probability of 5, we have 1, 2, 3, 4, 5. And the total possible outcome here is 1, 2, 3, 4, 1, 2, 3, 4. So 4 times 4 is 16. The total outcome here is 16. So we have 5. The 5 outcome with total 5. So the probability will be 5 out of 16. So more than 5. The answer is 9 of 16. Okay? Okay. By tree diagram, still with mutually exclusive outcome. So tree diagram is the third method that you can use to find out, to record the mutually exclusive outcome. Okay. Now, let's take this example, tossing a coin. Okay. Now, here will be the branch, and if we toss a coin, so we only have two outcomes, either heads or tail. Okay. So, the probability for the head will be half. Okay, and the probability of a tail will be also half, because we only have two total outcomes. So 1 out of 2 here for the head and 1 out of 2 for the tails, or you can use decimal here. Okay, 0.5. And this one is the tree diagram. Okay, once you have the branch and you put the probability here, and here will be the events. Okay, here will be the events, the outcome. In the first slide just now, it is about the first flip. Okay, once we flip again, still we have two outcome. It's either head or tails. Okay, so for each of the first flip, you split again with 2 branch like this. Okay, you split again with 2 branch like this, and still, okay, if the previously the head is 0.5 or half, so it will still half here 0.5, and the tail is also 0.5 half. Okay, same goes with the parts here. And now we extend our branch already for the second flip. And how you going to read the outcome? How you going to read the outcome is like this. Okay, this is the head and this is the head. That is how you got heads here. Okay, we have still the heads and the tail, so this is how you got heads and tails. Alright, and here is the tail, and the second flip is the head, so tails, head. Okay, and then tails with tails here. So this will be the outcomes. Alright, and this one is what we call as tree diagram. So how are you going to find probability through this tree diagram? Okay, just now you already find out the branches for the tree diagram, correct? So how are you going to find the probability? You need to multiply the probability of the branches. Okay, so how? This one. Okay, 0.5. You multiply with 0.5 will give you 0.25. And same goes to the next one. 0.5 multiply with 0.5. Okay, again 0.5 here, multiply with 0.5 here, and 0.5 here, multiply with 0.5 here. That is how you find the probability of the outcome. And once you complete already the outcome, and if you realize here, when you add them all, you will get 1. Okay, and the sum of the probability should always equal to 1. The maximum is 1. Note that the sum of the probability of all of the outcomes should always equal to 1. Okay, and from this point, you can use your probability tree diagram to draw several conclusions, such as the probability of getting heads first and tails second is 0.5, 0.5, 0.25. The probability of getting at least one tails from 2 consecutive flips is 0.25 plus 0.25 plus 0.25 equal to 0.75. You can try this one, find it by yourself. And last one, it can be used to find the probability of getting both a head and a tail is 0.25 plus 0.25, and the answer is 0.5. And please do not confuse. The first one is the outcome you need to multiply. Okay, the outcome for each branches you need to multiply, and here the plus is the outcome for the result of the branches. Okay, the result of the branches, that the one that you're going to add. Okay, please do not confuse between when to use multiply and when to use addition. Now, example 10. A football team has 2 matches to play. The probability that the team wins is 0.6. The probability that the team draws is 0.3. When the information given in decimal, so just keep it decimal. You don't need to change it into fraction. Okay. And for part A, you need to complete the tree diagram. And for part B, you need to work out the probability that the team will win both matches. Okay. So here will be the three diagrams. For the first match, we have win 0.6 and draw is 0.3. And remember, the maximum for probability is 1. Okay, so 1 minus 0.6 minus 0.3 and loss will be 0.1. Repeating the same value 0.6, 0.3 and 0.1 for the second match. Okay, like this. Because for this football team, they have 2 matches, right? So just copy down the value here and then look for both win. Okay, so when we look for both win, we need to look for the first match is win and the second match is win. Okay, so we only have this one. Okay, we only have this one. And how you're going to combine the probability for each of the branches? We need to multiply. Okay, so the answer is 0.6 times this one, 0.6 times with 0.6. Okay, that is how you got 0.36. And this will be your final answer. Okay, example 11. Kawim is playing darts. He throws 2 darts aiming for a bull's eye. The probability Kawim hits the bull's eye on his first throw is 1/4. The probability he hits the bull's eye on his second throw is 1/3. Okay, if you have two events combined in when you have two events combined together, that is the hint for mutually exclusive outcome. So you need to recall your three methods. It's either listing, by table, or by tree diagram. But in these questions, you're given the tree diagram. So your task for part A is you need to complete the tree diagram. And the second one, you need to work out the probability Kawim hits the bullseye at least once. Okay, I give you 2 minutes to try. One minute left. Okay, now we complete the tree diagram first. So here is 1/4. So miss will be 3/4. Okay, 3 out of 4. Right? When the hit is 1/3, so miss will be 2/3. Follow the same information for part here. Just copy it down. So this one, right? And probability that Kawim hits the bullseye at least once. That means both of the throw hit the bullseye. Okay, and remember how we combine the probability of the first branch and the second branch, you must multiply. Okay, and the second part, hit for the first throw and second miss the throw. Okay, the question one at least once, right? So at least for the first throw, Kawim hits the bullseye, and the second one, the third one will be this one. The first throw, Kawim missed the bullseye, missed the throw, and the second throw, he able to hit the bullseye. Okay, and remember how we're going to connect the probability of the first row with the probability of second row. We need to multiply. Okay, so P H hash representing hit. Okay, 1/4 times 1/3 will give you 1 out of 12, and then here 1/4 times 2/3 will give you 2 out of 12, and last one, miss and hit 3/4 times 1/3 will give you 3/12. Okay, and how are we going to combine this to find the probability of at least once? This one, we add all of them. Okay, like this. And your final answer is 6 out of 12. When you simplify, it become half. So the answer is half. Now let's move to example 12, the last example for mutually exclusive outcome. And a running club has 200 members. 120 of the club members are female. 80 of the female members are over 18. 50 of the club members are under 18. Complete the tree diagram to show this information. And second one, find the probability that a member of the club chosen at random is under 18. I give you 2 minutes to try. One minute left. Okay, now let us complete the tree diagram. A running club has 200 members, so 120 of the club members are female. And then 80 of the female members are over 18. Here, 50 of the club members are under 18. So here we don't have enough information to proceed that 50 of the club members are under 18, because we didn't know the members are female or male. Okay, and here you can complete this under 18. So 40, right? And if female here is 120, the total is 200. Therefore, the male will be 200 minus 120. Okay, and before that, here you are given 50 of the club members are under 18, right? And here you got 40. So When the underacting female is 40, therefore the underacting of male will be 10. Okay, so back to this. 200 minus 120 will give you 80. Okay, so 80 minus 10 will give you 70. So now we already complete our tree diagram. Okay, now you need to find out the probability under 18. Okay, probability under 18, so you need to focus this one because this one is already probability. So 40 and 10. Okay, so we'll get 50 out of 200 and the answer is 1 quarter. Our next subtopic, theoretical probability and experimental probability. At the end of the lesson, students should be able to, this will be the learning objectives. First, estimate probabilities based on data collected from simple data collected from experiments. Second, explain that if an experiment is repeated, there will usually be different outcomes. And last one, explain that increasing the number of trials will lead to better estimates of probability, which will approach the theoretical probability. Steps to success. First, identify theoretical probability and experimental probability. Repeat the experimental probability to get different outcomes. And last one, experience that increasing the number of trials will approach the theoretical probability. Okay? Don't forget to copy this down in your notes. Now, let us review theoretical probability and experimental probability. Theoretical probability is based on knowledge and mathematics, while the experimental probability is based on trials or experiments. Okay, so here will be the formula and how this theoretical probability works. We take a coin, when we toss a coin, and we know that for sure we only have two outcomes, right? Either it is about head or tail, right? But difference from experimental probability, we do an experiment, we toss the coin several times and then recorded how many times that we recorded head and how many times that we recorded tail. Okay, so it depends on the trial and experimental experiment that you take for that tossing the coin. Okay, that is how you got 3 out of 10, 7 out of 10. Why 10? 10 is the how many times that you try to do the experiment, right? Now let us review example 13. In this table shows the result of a survey that asked 20 students about their favorite breakfast. Okay, and we have eggs 10, cereal 2, and toast 8. What is the probability that a randomly selected student prefers egg? So these questions only ask you about probability. And you must know the total altogether. Here is 20. So we take x 10. Okay. 10 out of 20. Simplify. And you should get half. Alright. Right. Now, example 14. A coin was tossed 200 times and the number of tails observed was 102. So here you need to find out the theoretical probability of getting tails. And for part B, experimental probability of getting tails. And you need to put your answer in simplest form. Alright, I give you 2 minutes to try. 1 minute left. Okay, now for part A, you need to find out the theoretical probability, and remember, theoretical probability is it's only based on knowledge, and knowledge that we know about coins is they only have two outcomes. It's either head or tails, right? So your theoretical probability will get theoretical probability of getting tails will be half, all right? And the information here relevant for experimental probability. Okay, I repeat myself. Information here only relevant for experimental probability. So experimental probability of getting tails will be 102 divided by 200, and you need to give your answer in simplest form. So your final answer will be 51 out of 100. Next, example 15. When Faris spun the spinner, he got a vowel 34 times out of 50 spins. Okay, what is the experimental probability? And remember, when we talk about experimental probability, the information above here is related to the experimental probability. And for theoretical probability, we only based on the knowledge, and as we can see on this diagram, we only have 4 possible outcomes. Okay, so how are you going to find the experimental probability? Like this. Okay, uh, so the probability that Faris will got vowels will be 34 out of 50. Okay, and when we simplify, it becomes 17 out of 25. Therefore, the experimental probability will be 17 out of 25. And theoretical probability here, we only focus with that 4. Okay, this one. 4, and vowels are A, E, I, O, U. So we only have one vowel here. Alright? So probability of vowel 1 out of 4. Alright? Next, example 16. A game at a festival challenge people to throw a baseball through a tire. Of the first 68 participants, 3 people won the gold prize, 12 won the silver prize, and 15 won the bronze prize. What is the experimental of not winning any of these 3 prizes? These 3 prizes are gold prize, silver prize, and bronze prize. I will give you 2 minutes to try. 1 minute left. Okay, now the question asks you about experimental probability, so you need to pay attention with the statement given. Alright, now solution: winning any 3 prizes, when we calculate them all, we have 30. Alright, 3 plus 12 plus 15 will give you 30. And the question asks you about of not winning. Okay, so not winning, we have 68 participants, so minus with 30 participants, therefore the remaining participant will be 38. And we want the probability, not the value for not winning. Okay, so we move with the probability. Probability of not winning is equal to 38 out of 68 and equal to 19 out of 34, and your final answer will be 19 out of 34. Next, example 17. Razin fired 200 arrows at a target and hit the target 168 times. Find the experimental probability of Razin hitting the target. Okay, so how are you going to solve these questions? I will give you 2 minutes to try. One minute left. Alright, now solution. Probability of hitting the target will be 168 divided by 200, and when we simplify it will become 21 out of 25. Alright, as simple as that. Now let us move to the making predictions with experimental probability. And remember, when we take more trials in experimental probability, it will approaching the theoretical probability. And how this happen, okay, that is what we're going to evaluate, and that will be what we're going to find in our next slide. All right. Okay, now we have two examples here, example 18 and example 19. I will give you 2 minutes to try first, 2 minutes from now. One minute left. Okay, now for example 18, we need to find the experimental probability of waiting for a train. Okay, so waiting for a train, we have 58 here. So 58 out of 227. If you cannot run off anymore, so 58 out of 227 will be your final answer. All right. For example 19, the question asks you how many out of 560 will not have defects. Okay, and here when they check 320 cars, 12 of them have defects. So what about 560? I will do in terms of ratio like this. You need to find the defects first for your step 1. When we have 320 cars and the defects is 12, all right? And what about 560? I put y here. So use cross multiplication. Calculate y, you should get 21. Okay, but this 21 is defects. And the question asks you about not have defects. And because of that, you proceed with step 2 to find that not defects of 560. Don't use 320. Okay, don't use 320 because the question interested with 560. How many cars that will not have defects if it is 560? So not defects equal to 560 minus 21, and the answer is 539. Alright? Now, moving on with example 20, the probability that one wristband is defective is 1 out of 20. In a case of 840 wristbands, how many will be defective? Alright, you are given the probability of defective already. So, the question here is about defective. Therefore, you can automatically use this 1 out of 20 and you multiply with this 840 like this. Okay, and the answer is 42. Which probability is more accurate? Theoretical probability or experimental probability? Now, theoretical probability is more accurate than experimental probability. Alright? However, the results of experimental probability are close to theoretical only if the number of trials is more in numbers. The more you try, the more you take the trial for the experiment, then it will approach to the theoretical probability. Alright? So, let us continue with the next example. Example 21. 21a. If you flip a coin, what is the theoretical probability that you will flip a head? Give your answer in percentage. And for part B, suppose you perform 2 experiments. In the first one, you flip a coin 20 times and counted the number of times heads came up. In the second experiment, you flip a coin 2000 times and counted the number of times heads came up. In which experiment are you more likely to get heads 50% of the time, and why? Alright? I give you 2 minutes to try. One minute left. Okay, now. For part A, the question asks you about theoretical probability, so you need to find out the probability of flip a heads, okay? And give your answer in percentage. So, probability of head equal to half, and it is 50%, okay? And then in which experiments are you more likely to get heads 50% of the time, and why? The answer is 2000. Reason, it is because the more trials you perform, the more likely it is your result will match theoretical probability. Alright, so this is how you answer this kind of questions if it come up in exam. Okay, last example, example 22. There are 12 balls in the box with red, blue, and green. And for part A, you need to find the theoretical probability of getting red ball. So you just focus with the given element here. So red, blue, and green. Therefore, the probability will be 1 out of 3. 1 out of 3 is the final answer. And for part B, find the experimental probability of getting red ball if the number of trials is 10. Okay, the number of trials is 10. So the probability of red will be 5 out of 10. And when we simplify, it will give you half. The second part, when we repeated the experiment 100 times, and your probability will be 36 out of 100, and once you simplify it will become 9 out of 25. And the last part, the experiment is repeated 3000 times, and the solution probability of red is 997 divided by 3000. Okay, and what you going to conclude here? What can you conclude here? Okay, for the conclusion, you need to relate the results of theoretical probability with the results of experimental probability. Okay, now if we change every of the fraction here become decimal like this, okay, then let us see which decimal of these 3 experiments here close to the decimal of theoretical probability. It's either trials of 10, trials of 100, or trials of 3000. If you can see here, the trials repeated 3000 is more approaching the theoretical probability. Therefore, the conclusion is, as the number of trials increases, the accuracy also increases because it is close to theoretical probability, as the number of trials is more in number. Okay, so by doing this slide, it will be our the end of our session. And don't forget to complete your notes and your worksheet. And as usual, we will stop our session by reciting dua. Thank you so much, and Assalamualaikum warahmatullahi wabarakatuh.
Doa selepas belajar. Bismillahirrahmanirrahim. Allahumma inni astaudi'uka ma 'allamtani fardudhu ilayya inda hajati ilaihi wala tansani ya rabbal alamin. Ya Allah, sesungguhnya aku menitipkan padamu ilmu-ilmu yang telah engkau ajarkan kepadaku, dan kembalikanlah kepadaku sewaktu aku memerlukannya kembali. Dan janganlah engkau lupakan aku kepada ilmu itu, wahai Tuhan yang memiliki semesta alam. Amin.